Hi guys, okay, here's Dr. Diaz, and I will try to solve some of the problems from the review. This is for helping all those kids, students who are in quarantine and have missed class. So okay, because I haven't done the Zoom videos, and it's kind of nasty for me to do it, and I don't have the equipment. Okay, I'm gonna do these videos, I'm gonna post it in class, and you probably can see and be prepared for the review. So let's start with the first one, and I'll be talking a little bit fast to save time. So pay attention. Okay, the first thing is, let's solve this problem. It says solve and graph the solution set on the number line. So the first thing we're going to do is rewrite the equation. And we have here a 6, 2x plus 15 smaller than 18x plus 48. So the first thing we're going to do, we use a small one, we're going to distribute these two among these two terms. So 6 times 2 is going to be 12x, and 6 times 15 is going to be 90, smaller than, well, we have 18x plus 48. The next thing we're going to do now is regroup some terms. We're going to send, for example, the variables one side of the equation, which I guess the 12x are going to send it this way, and the constant, the 48, are going to send it the other way. So we regrouping variables one side, constants or numbers the other side of the equation, or the inequality. So in this case, we have 90 minus 48, and the reason is because when 48 crosses the unequal sign, it will change its sign, smaller than 18x minus 12x, and the same thing happens with 12. It will change its sign. So 90 minus 48 is going to be 42, and this is smaller than 6x. We divide both sides by 6, yes, 42 divided by 6, smaller than 6 divided by 6x, and we will get that 7 is smaller than x. But some things for us is much easier reading from left to right. So it means x is bigger than 7. And then you go here in the line number, since everybody's putting here 7, have 7, so then we're going to say, okay, all these numbers that it counts are bigger, actually is bigger than 7. Let's put a parenthesis kind of thing, and it goes all the way to plus infinity. So the solution for this one, here we have it. This is 1. The other would be what? Writing this in the interval notation, which is going to be 7 all the way to plus infinity. And the answer for that one is going to be, oh, actually, sorry, it does not include 7, so it's a parenthesis. Oh, what a mistake. It's 7, yeah, parenthesis, not including 7. So the answer will be then is B. Here is one. Yeah, here's the graph. It looks like the one we did. Perfect. Sorry about that. It's not including 7, so it's a parenthesis. So let's go to the next one. Oh, we spent too much time doing that one. Okay, this one, what we're going to do here now is we're going to solve. This is an AND, so it's a bounded problem. So we have 7x plus 5 bigger than or equal than 33, and 8x plus 9 bigger than or equal than 49. And what we're going to do in each case, we're going to solve for the variable x. So this 5, we send it to the other side. This 9, we send it to the other side. We will have 7x is bigger than or equal than 33 minus 5. And let's divide this into two pieces. Then this one is going to be 8x is bigger or equal than 49 minus 9. Okay, 33 minus 5 is 28. So we have 7x is bigger or equal than 28. And here we have 8x is bigger or equal than 40. We divide both sides by 7 in this case, and here by 8. So we will have here that x is bigger than or equal than 4, and here x is bigger than or equal than 5. Ooh, funny, interesting thing. Both are looking the same direction. Okay, let's look at the graph here. And here we have 4 if we follow the same graph as the one below, and here is 5. Now if we look for 4, let's use 4 with the red one. These are the numbers that include 4. Okay, this is going to disappear. Oh yeah, there's leprechauns here. And this one goes all the way to plus infinity. If we use the 5, let's use the green one. This one goes all the way to plus infinity. They both look in the same direction. But look, the 4 includes 5, but the 5 does not include 4. And because it's an and, when you write this thing here, x bigger or equal than 4, intersection, x bigger or equal than 5, it has to be the numbers that are included that are in both. And only 5s will have both set numbers of 4 and 5, except for 4 because it's not in 5. So this is equal to x bigger than or equal than 5. Bigger or equal than 5, if you put in the interval notation, it will be 5 all the way to plus infinite, right? Because it includes 5 and is bigger or equal. So the only one that has that thing is 8. Yeah, here we have it. Perfect. Good. I hope that helps a little bit. So let's go to the next one. Oh, look at this one. This is an and 2. It's bounded. So what we're going to do here is isolate it for x. So how do we do that? First, we have to get rid of the 3. Well, actually, this is 3/2 and 2/2. So first, let's break this fraction here. Let's put here 0, smaller or equal than 2x plus 3, and let's divide it individually by 2, smaller than 4. Yeah, so I broke the parentheses into 2 terms, and what I'm going to do, there's a 0 that disappears for whatever reason, I think it's leprechauns. So what we're going to do now is we're going to subtract each term, each side of this expression, 3/2. So the first one is going to be 0 minus 3/2, smaller or equal than 2 divided by 2 is just x, right? Plus 3/2 minus 3/2, smaller than 4 minus 3/2. We know this one is going to give us negative 3/2. Smaller and equal than x, smaller and smaller actually only, right? Yeah, smaller. Don't put the smaller equal. Let me erase that thing. I'm going to save this for a second. Let me stop here for a second. And this is going to be equal to 5/2. And you know, sometimes it's going to happen in the video that all of a sudden all the equations are going to be solved without you seeing, because I'm trying to save time. So what I did here with this one here is this. 4 minus 3/2, the common denominator is going to be 2, so I had to multiply 2 and 2, denominator and numerator. So we will have 8/2, which is equal to 4 minus 3/2. It will give us 5/2. That's what we get here, 5/2. So if we write this in the interval notation, it will be minus 3/2 and 5/2 in parentheses, not included because it's just smaller. Now we go look here. Oh, apparently A is the one. Yes, 8 is the one, because if we put here negative 3/2, if this is 0, this is 1, this is 2, 3/2 is actually negative. This is negative 1, negative 2. It's somewhere in between here. It's negative 1.5. So this one we put a bar. We put included the bracket, and here we go all the way to 5/2, which actually is 2.5. This is 1, this is 2, this is 3. So 2.5 is somewhere here, and that's it. It's this one. Yay! It's A. Good. So now let's go to the next one. Scrolling down. Okay. Oh, another one. Okay, but this is one of those OR divergence. So this is what we have. X minus 8 is bigger than 2. If you remember, one of the rules says absolute value U bigger than C. It means that U is bigger than C, or U is much smaller than negative C. So if we break here the absolute value, let's put the line here. One, it says that x minus 8 is bigger than 2. The other one, that x minus 8 is smaller than negative 2. We solve both sides for x. So we send 8 to the other side, 8 to the other side. This one is going to give us 8. X actually is bigger than 2 plus 8. Oh, so x is bigger than 10. Look at that. Super cool. Okay, I'm going to stop here for a second. Then we do the same thing here to the other side. We send 8 to the other side, so it's going to be x is smaller than negative 2 plus 8. X is smaller than 6. Okay, so we have these two. One that says x is bigger than 10. We have this one that says x is smaller than 6. Aha! So let's go here. 6, much smaller than 6. We put a parenthesis, goes all the way this way. Much bigger than 10. Without including 10, it goes in parenthesis, goes this way. So which of these one has that notation? And I think, oh wait, we can put this in interval notation. This one will be 6 is a bigger number, so it's going to be minus infinite all the way up to 6. This one, 10 is a small number, so it's 10 to plus infinite. Okay, since this is smaller, it will be minus infinite to 6 union 10 to plus infinite. Okay, which one has this notation out of those 4 there? It is B. No, actually it's not B. Actually, yes, it's B. I'm sorry, I get confused because I thought B, this graph is this one. Yeah, because this is this graph. Yay! Okay, good. Next. This PowerPoint is getting, this thing is getting longer. Let's do this one. Shut up, one. Okay, let's do this one. Now, we're going to do the same thing with absolute value. The first thing we're going to do is we're going to send 7 to the other side. Okay, when we send 7 to the other side, we get absolute value 6x plus 2 is equal to 12 minus 7. Right? Absolute value 6x plus 2 is equal to 5. Okay, it's positive, so it passed the smell test or whatever test it is. We know it's going to work, so we have to keep going. And when we have something like this, absolute value of u equal to a constant, this means what? Well, it's equal to c, and it's equal to minus c, because as you remember, there's 2 possible numbers that could be correct. Like if we put absolute value of x is equal to 2, well, there's 2 possible values. You can do absolute value of 2, which is equal to 2, and you can do absolute value of negative 2, which is also 2. That's why now, when we work this problem, let me use a different color, we're going to use what? 6x plus 2 equal to 5, and 6x plus 2 equal to negative 5, because there's the possible answer. We send 2 to the other side. Send 2 to the other side. It's going to be 6x is equal to 5 minus 2. 6x is equal to 3. We divide by 6 both sides, and we got x is equal to 1/2. Yay! This is 1/2. Looks like a y. Okay. Then we do the same thing with this fellow. We send 2 to the other side. We got 6x is equal to negative 5 minus 2. 6x is equal to negative 7. Divide by 6 both sides, and x is equal to negative 7/6. Yay! So, okay, what is the solution? It will be negative. Oh, wait. How do we know this is true? Because we have to substitute here and check it, verify. But unfortunately, they're giving you all 4 answers, and the only one that looks like this, 1/2 and negative 7/6 is B. Yay! But you can verify. The way you verify, you put 1/2 here. You put this is going to be 3 plus 2 is 5 plus 7. Yes, this is true. Then you put 7/6 here. Divided by 6 is going to be negative 7. Plus 2 is going to be negative 5. Absolute value negative 5 is 5 plus 7. Yes, these are the correct answers, so to speak. So now let's go to the next one. Yay. Okay, you remember this one because I'm going to ask this on the test. The Java Joe's thingy. And how we do this one? Okay, first they say here, okay, the table compares the average number of lattes purchased at Java Joe's to the average number of cappuccinos purchased at Java Joe's for 5 different months. And they're asking you, let's go here. This one is asking you a month in which the lattes are bigger than 1700. And let's go here to the lattes. So we're going to put here lattes. And those are January. January. Then we go, okay, bigger than 1700 for latte. Okay, we got March. Oops, March. Other, no, June, September, and November. Perfect. And it's an intersection. Whoops. Now we go here for X is a month in which a cappuccino is less than 2,000. Less than 2,000 is everybody except for November. So it's going to be January, March, June, September. Okay, so since it's in the intersection, what does these two numbers have? These two sets have in common? Well, the first one is January because it's in both, right? Let's put it here. January, which is the next one. March. What's the last one? September. And September because November is here but not here. And June is here but not here, so that's not what they have in common. What they have in common is just January, March, and September. Okay, September. You see, the leprechauns are telling you. Okay, good. So the answer will be B. Yay! Next, let's go to the next. We have two problems here. This is factoring trinomials. Okay, wait, don't go too far. Okay, obviously there's a monkey messing up with this thing. Okay, let's do the first one. Okay, we got this one. It says x squared minus x minus 42. And basically what we're doing is looking for two numbers that adding up will give us -1, which is the coefficient of x, and the same two numbers that you're multiplying is going to give us -42. You're looking just for factors of 42, 6 and 7. But because it's -1, this must be what? -7, +6, -7, +6. So the factorization of this one is going to be what? X minus 7, x plus 6. And if in this, it's not in this order, sometimes you can see it like this: x plus 6, x minus 7. It doesn't matter, it's actually correct, the same thing. And we can see that the answer here is B. Yeah, there's no other that says that, right? The prime, they're not going to be prime. They're always going to give you an answer. Perfect. We did 17. Let's do 18 here next to it. And this one is x squared plus 5x minus 50. And again, we're looking for two numbers that adding up will give you 5. And the same two numbers that multiplying will give you 50. Oh, it's -50? Oh yeah, it's -50. Okay, so let's look at those two numbers. Factors of 50 is 10 and 5, right? But it has to be positive 10 because 5 is positive, and -5, positive 10 and -5. And the reason one of them has to be negative is because we have -50. So what's the factorization of this fellow here? Is going to be what? X minus 5, x plus 10, and sometimes they appear like x plus 10, x minus 5. But it doesn't matter, it's the same. And which one is that one? Again, it's B. Yeah, too many B's. Hey, don't think though the test all the answers are going to be B. Okay, be careful with that. Just pure coincidence. Okay, and remember, this is a video, so you can watch it over and stop it and go at your own pace. You don't need to watch it, but I need to go a little bit faster because I don't have much time. It's already 17 minutes here. Okay, so look at this one. You had to use substitution. So you said let u be equal to x squared, so u squared is equal to x to the 4th. Now you reduce this polynomial into this thing, u squared minus 12u plus 35, and then you do the same factorization as usual, which is which two numbers that adding up will give you -12, and the same two numbers that multiplying will give you 35. We know this factor of 35, and both have to be negative because 35 is positive but 12 is negative. And yes, exactly, you say it, it's 5 and 7. 5, but -5, -7, -5, -7. So that means that factorization with this fellow here is going to be what? U minus 5, U minus 7. Okay, minus 7. There's a leprechaun here. Let me stop it. Okay, U minus 7. But there is no U in the answer. There are X. Okay, but because then you have to transform this back into who you call U, and we call U. Oh, we're supposed to say here, it says legs. Leprechauns, tell you nasty creatures. This one is going to be what? X squared minus 5, x squared minus 7. And anyone that has x squared minus 5, here it is, it's C. Told you all the time is B. Here is C. Perfect. Next. Gonna run out of voice here. Okay, so, oh, look at one. This is a nasty one that you have to do the cross thingy majingy. Let's do it here. Let's do it here. Actually, no, there's no space there. Let's do it here anyway. Done. You multiply 2 times 35 is going to be 70. All right, you know how to do this one, right? When you have a polynomial like this, let me write it here. 2x squared, it says y, I'm sorry. Okay, let's go with x, it doesn't matter. 19x plus 35. What you do is you multiply this guy times this guy, and it goes here, which 2 times 35 is 70. Perfect. Now, okay, and this one goes here, -19. Then we're looking for two numbers that adding up will give us negative 19. The same two numbers are multiplying is going to give us 70. So we're looking for factors of 70. And I would suggest 5 and 14, because 70 divided by 5 is 14. Oh yeah, it's actually negative 5 and negative 14. Negative 5 and negative 14. So we 14, not 15. So we put here negative 14. We put here negative 5. Both is going to be divided by the leading coefficient, which in this case is 2. Here 2. We divide both by 2. By 2 is the leading coefficient. This 2 here. It's going to disappear. Okay, the 2. So 14 divided by 2 is negative 7. Actually, this is negative 7. But you will put 7 divided by 1. And we have 5 halves. So here we go. We have on one side negative 7 divided by 1. And the other one is negative 5 half. So how the factor term looks for this one? Yeah, it's going to be x minus 7. Or in this case, it will be y minus 7. Right? Because it's like 1 times y minus 7. This one is going to be 2 times y minus 5. So it's going to be 2y minus 5. So the complete factorization of this thing is going to be what? Y minus 7, 2y minus 5. And that one looks like D. Here it is. I don't need to look at it, it's already here. Because this is the same as writing 2y minus 5, y minus 7. Yay, it's D. Okay, perfect. Let's go to the next one, because we're wasting too much time there. Sorry about that. Aha! Factor the difference of two squares. You remember? A squared minus b squared is equal to a minus b and a plus b. So in this case, we have 81 x squared minus 16, and both happen to be perfect square, because 81 is the same as 9x squared, and 16 is going to be 4 squared. So this guy is going to be a is equal to 9x. B is going to be equal to 4. So using this equation here, the factorization of this fellow here is going to be a, which is 9, 9x minus b, which is 4, times a, which is 9x, plus b, which is 4. So the answer has to be, oh, here it is. It's C. Yay! Okay, this is not, it is never prime. Okay, because I don't like the prime numbers. I mean, I like the prime numbers. I don't like the prime problems here. So let's go to the next one. Okay, this is another one that is kind of nasty. But hey, it says perfect square trinomial. You know the perfect square trinomial, the one that says a squared plus 2ab plus b squared. Yeah, that's a perfect square trinomial. It's the same as a plus b squared. There it is. So in this case, we need to look at the, well, you see the a disappear because they are leprechauns. The first one has to be a perfect square, and the last one has to be a perfect square. And the first one it is, because this is 7x. Let's put it here square. The last one is 1 square. So if you use this analysis, and the middle one is going to be 2ab, because this 7 is going to be a is equal to 7. This one is b is equal to 1. And the middle term is going to be 2ab, which is going to be 2 times 7 times 1. And you know, the variable is going to be x, so this is actually 14. Aha, there it is. Coefficient 14, we got it here. The 1, we got it here. And the 49, we got it here is 7 squared, right? Yep. So, the factorization of this one is going to be what? A, which is 7x. Well, actually, we should put 7x. 7x plus 1 squared. And that one, you see, here it is. It is not this one, because this is a difference 2 squared. It is not prime. And this one doesn't make any sense, because this one, if you do FOIL with this one, you're going to get x squared is equal to 14x plus 49. It's actually the numbers here inverted. So it has to be B. Well, it is B. Okay, so let's go to the next one. We already have 24 minutes here. Okay, the difference of two cubes. Now you have to remember these equations. A cubed minus B cubed b cubed. I said cube and the thing wrote something else. It's going to be a minus b, a squared plus ab plus b squared. Okay, so if we follow the formula, we have this one, x cubed minus 27, right? This is x. Well, let's put a is equal to x, and b is equal to 3, because you can rewrite this equation as x cubed minus 3 cubed. Okay, let me stop in a second here. Okay, and well, we will have here, by using the formula, is a minus b, so it's going to be x minus 3, and by this you know it has to be one of the first two, I mean a or c, times a squared, which is x squared, plus, let's put here b squared, that's 9, plus ab, which is 3x plus 9, and that one is actually the first one, 8. Perfect. Okay, so let me stop here the video. Let me stop here the video and then do another section, because it's getting too big. In a second, let me stop it.